All right, so here are the answers to the last test this spring before our final, chapter 7 through 9. The first one is just asking for that confidence interval. If I saw any errors on this one, sometimes they didn't use, for some reason, the p hat. They try to use the 13% or something different. Remember, this is always the sample proportion we're interested in. And so if you do a 95%, remember that's 1.96, and we always use z with proportions, right? So then there's the 95% confidence interval is, so we're 95% confident the true proportion of, what is it, single parent households is between 16.5 and 33.5%. So and the principal says it's 13%. So could the principal be right?
No.
They could be right. But what's the probability that they're right? It's really low. So based on your confidence interval, based on our confidence interval, is there evidence to support the claim? No, based on what we're saying with the confidence interval. And then it says, why or why not? 13% is not in the interval. And then one of the other questions, I think it's important for us to realize, have we proven the principle wrong? No. All we're saying is we have significant evidence to the contrary, right? This is important words to use. Any questions on that one? Good? Most people did very well on that one. Okay, number 2, we have a hypothesis test. Remember, this is with proportions, so we want to make sure we use P, and the null always has the equal sign, right? So some of you forgot that the equal sign was with the null, so you might want to fix that if you made that mistake. And we're checking to see if the percentage of defects is over 3% or not, significantly over 3%. So there's our null and alternative. And when we're doing proportions, again, we use z, and this is our z test for proportions, and we get our test statistic was 4.9%, and that's 1.03, essentially one standard deviation above normal. The question is that rare enough for us to reject the null hypothesis? Well, if you look up 1.03 on your z table, you get about 15%. So there's about a 15% chance of getting that much variability or more. And since p is greater than 0.01, that was our alpha level right here, we're going to say do not reject the null hypothesis. There's not significant evidence to say the process is out of control. Yeah?
I kind of understand how you know when to reject and when not to reject.
Yes.
But then again, I don't, because that's what I got wrong pretty much on all of my hypotheses.
So when is the only time we reject the null hypothesis? If we experience something that is so rare that it's lower than our significance level. So we'd have to experience something that happens less than 1% of the time before we reject. That's the only time, so that's pretty much it. Some of you made the mistake of, you'd say, do not reject, there is significant evidence. So you might want to note to self, if you don't reject, there's not significant evidence. If you do reject, then there is significant evidence, right? To reject her. So those kind of pair together. And then what's a type 1 and type 2 errors? So we had some issues with this. Remember, type 1 is when you reject the null hypothesis and you're wrong. And in this case, that's saying the process is out of control, but it really isn't. A lot of you would say the process is out of control, but it's an error. So describe what the error is. Yes, you say it's out of control, but you are wrong. Okay, that's important that you describe what the error is, not what you think is going on. So make sure you add that. I'll be a little more particular about that on the final. I tried to be forgiving. Sometimes you mess these up. Some people would say, okay, type 2, do not reject the null, and you're wrong. Say the process is okay, but it's really not. Sometimes you would flip-flop those. If the verbiage was right, I try to only take maybe 1 point off sometimes. Sometimes I have to take both points off. But in general, if you said reject and wrong, do not reject and wrong, I give you 1 point for that, but it needs to be in this situation. It needs to be in context here. Okay? Yes?
So on the final, like I've got for my type 1, reject the
null
hypothesis and the wrong. P does not equal 0.03, but are wrong. Are you going to accept that for full points on the final, or should
you want to say what that means? You got to say what that means. You're saying no, the process is higher. There's more than 3% errors, but it's really not. Okay. That would be the error. So just be a little more I'm going to be a little more particular on the final about your verbiage on that. Okay? Is that cool? Ready to go to 3? All right, and number 3, again, a null and alternative hypothesis, but we're talking about means here. So our null hypothesis is that the wait time is 10 minutes. The alternative is that is less than 10 minutes. If we calculate our t statistic here, we get negative 5.14, and just based on everything we know, that's significantly lower, isn't it? That is going to be a long ways away. And if you look up at that p-value, you can say it's really small or less than 0.005 or whatever it is, because our t-table, here, let me pull up the t-table here quick. And how many degrees of freedom were there in that one? 17 degrees of freedom. And if you look for 5, that's just way out here, isn't it? So we know the probability is going to be definitely less than, it's going to be out here way less than 0.005. So what's that mean if we experience something that rare? We should reject the null because our p-value is less than 0.01. There is significant evidence the wait time is less than 10 minutes. So what's a type 1 error? You say the wait time is less than 10 minutes, and you're wrong. The alternative is say, you know, the wait time is 10 minutes, and you're wrong. So that's the type 1 and type 2. And then to do a 99% confidence interval, the only mistake usually I'd see on here is this t statistic. And that, again, comes from the t-table. And we look at row, what is it again? Row 17, and there it is. There's the 99%. That's our multiplier, and you can always look at the bottom for that, right?
Dan, can I read you my?
Yep, go.
My type 1 error was marked wrong. I just don't really understand.
Okay, read
I
that.
put rejecting the null when your p-value is greater than 0.01, or saying that we have significant evidence to believe that the average wait time is more than 10 minutes if we do not.
It's not really about how you say it or what you're saying there is I think you were trying to say that you didn't reject. From your wording, it sounds like you're saying, yeah, it's 10 minutes, or yeah, it's more than 10 minutes, or yeah, our p-value was high. We're not saying you made an error in the statistical analysis. We're saying we made an error just by doing stats. We could do everything right and make an error. That's what I'm trying to get you to describe. We did the analysis, we got this p-value, we rejected a null, and we still can be wrong, right? Because there's always a chance we're wrong. And I just want you to describe what does that mean, being wrong in this case. That means we have the potential for making a type 1 error here, don't we? We reject the null, and then
Which would be saying that the wait time is more than 10 minutes would be rejecting.
reject the null says the wait time is less than 10 minutes. Because that was our alternative hypothesis. Because we're trying to say the wait time is under 10 minutes.
Okay.
Is that cool?
Yeah.
So, yeah, I remember reading yours and I was like, it's close. So, well, maybe I held you at a higher standard than the rest of the class. You okay with that? Yeah, but focus on what happens if I make an error, even if I do the analysis right. That's what that means. Not saying I made a math error, right? Not saying that I didn't have the appropriate p-value. Not saying I didn't have the right significance level. We're saying what happens if and if you know you're making an error, wouldn't you stop it? Well, I'm making a type 1 error here, but I don't care. No, you don't. You wouldn't do that, right? Even though that happens, but that's the crappy thing is we can make errors and we don't know, right? But the acknowledgement of that needs to be, described. And what does that look like? And what's the consequence of making that error? Does anybody die if we make that here? No, this is a good thing. Just wait time at the bank doesn't, a life or death situation. Well, for some people, I know some people get really worried about wait time. Like we were waiting in line to drop off kids at school, and all of a sudden this crazy mom rips off in the left lane, rips through everybody, starts honking her horn, and tries to drop her kid off because somebody's taking a little too long pulling out. I'm like, okay, that's a potential life and death situation. What if some child, I don't know, was getting out of a car and was like crossing the street? That is awful. I couldn't believe she did that. I was like, and she wasn't mad at me, thank God, but just some other guy in front of me. But anyway. All right, number 4. This is with 2 proportions. So remember, your null hypothesis has 2 population proportions we're comparing. We're checking the difference between these 2. Yeah.
So, because I didn't remember that it's P1 equals P2, I put A will be use that. as the
Yeah,
correct
so
physical
that is,
sign.
yeah, you want to put P there. I only checked, it's worth 2 points, so I gave you 1. So yeah, make sure they're proportions, and this is a 2-tailed one. So you calculate your Z statistic, remember this is 0 here, and we get 0.97. So pretty much we're saying the proportion of smokers in the 20 through 24 and the proportion of smokers in 25 through 20, those 2 samples are about 1 standard deviation apart from each other. And based on what you've known from this class, is that a very significant difference? 1 standard deviation? No. If you look at the p-value, it's about 16%, and since it's 2-tailed, we actually double it and get 33%. So since p is greater than 0.05, do not reject. There's not significant evidence proportions are different.
So you don't multiply it, you don't times it by 2.
The p-value, yes.
You do the p-value and not the z-value.
No, we do not double. That would mean it would be twice as far out, which it's not. I mean, that'd be like saying the 2 proportions are twice as far from each other than they really are. We just double the probability because it's both tails. It's really over here too. Right? Is that cool? All right. Type 1 and type 2, reject the null and say proportions are different, but they're really not. Type 2 error is don't reject the null and say proportions are equal, but they're really not. So pretty much all those are about the same, aren't they? Just got to kind of tweak the context a little. Those should be like, especially if I put those in the final, it should be lob it up and knock it out of the park ones, hopefully. And then the 95% confidence interval, again, we use 1.96 because it's a Z, and we're finding the true difference. The true difference is, we think we're 95% confident the true difference is between -5 and +15%. If you flip-flop those, that's fine. If you had -15 and +5. Now, of course, I screwed up. It says, does the interval contain both percentages? What should that have said? It should have said, does the interval contain 0, right? So I didn't grade that part at all. So pretty much I just checked to see if you had the confidence interval right. On the final, I would ask, does the interval contain 0? And you would say, yes. Does that back up the fact that there is not a significant difference? Is it potentially no difference in these proportions? We could explain this variation just by random sampling, couldn't we? So we don't have enough evidence to say they're significantly different. Yeah?
Out of curiosity, how many decimals did you carry out?
Looks like 2 mostly. This one I got a little more because I'm like, hey, those are identical. If you had 1 there, I was cool with that.
I had 0.89, and I've done the math twice, and I took them out 1, 2, 3, 4, 5, 6, 7 decimal places.
Right here, 0.89. Maybe you made an error right here. Check your denominator. Make sure did you use the same one for both maybe, or mess up the sample sizes? It might have been a little error there. Did I count it wrong?
You took off 1 point.
Yeah, I just took off 1. I give you credit. So, and here's another key thing. Some people would just write down let's say they put down 0.8 for Z-score. I'd be like, okay, that's wrong. How'd you get that? I have no idea. 2 wrong, right? So if you actually filled in the numbers, I gave you at least a point. Then if you actually got the right number and p-value, I gave you the other point. So on your final, at least write down how you did it. So you can get some partial credit there.
Like, my numbers are exact. That's what I'm trying to figure out. Like, I just genuinely don't understand how you...
Well, I'll have to maybe watch you punch on your calculator and see. Because I'm pretty sure that's what you get. Or something pretty close. Between 0.97 and 1, somewhere in there. So if you got 0.8 something, that's what I'm curious. Maybe there's a parenthesis issue or order operations or square root or something. How about number 5? This is difference between 2 means. So our null hypothesis is the two means are equal. Men and women watch TV the same. Our alternative is that they're not the same. And then we calculate our t-statistic. We get negative 3.46. And if you look up negative 3.46, how many degrees of freedom are there? 14 plus 17 is what? 31, 29 degrees of freedom?
So you did it with equals does not equals?
Yes. I accepted greater than and less than, I think, too, for an alternative. If you made it one-tailed. And what was it? Again, we're out here, aren't we? We're way out here in row 29. So the probability is going to be less than 0.01. If you made it two-tailed, if it was one-tailed, it's less than 0.005. But either way, they're both less than what? What was the alpha level? 0.05. So
even though it says mean amount of time
right here.
women watch television is smaller, being not equals is okay?
Yes. Yep.
Why is that? 'Cause that
Um,
sounds like that's a less than.
Tests that claim that the mean amount of time watching television is smaller. Yeah. So you could actually have this too.
Well, that's what I had. I'm just asking that why is not equal?
Or
You can turn it into a two-tailed test.
yep. And you can do it either way because honestly, the only difference is your p-value is going to be less than 0.01 or 0.005. Both are appropriate. I accepted both. Yep.
I have a question.
Yeah.
What four numbers what are the four steps? So what four things are you basically?
Known alternative hypothesis, test statistic p-value, reject or not reject, explain in context.
Test statistic, which means
The t-score
the t-score,
and p-value, that's all step 2. So we get 2 points for known alternative, 2 points for test stat and p-value, 1 point for reject or not reject, 1 point for explaining in context. 6 points for each one of these. And then the type 1 and type 2 is 2 points, reject. So again, reject and say there is a difference when there really is not. Do not reject and say there's no difference, but there really is. And then there's the 95% confidence interval. The key part here is this 2.045. Where does that come from? Again, our T table. And what level is it? Right here, isn't it? 95%. Oops, sorry. There you go. 2.045. Cool? Yeah.
My explanation, I put there significant that the amount of time spent is less than 0.05. How is it done? Not like that. Because I did it.
Would you say that again? There is
I did it one-tailed, not two-tailed.
Yeah, that's fine. So what'd you say?
There is significant evidence that the mean amount of time spent is less than 0.05.
That's not right because it would be the mean amount of time watching TV is less than men. It has nothing to do with 0.05 hours of watching TV.
That was the significance of it.
Right. That's how you make a decision. What that means, and if I just said to you, hey, you know what? Women watch less than 0.05 hours of TV. That makes, like, huh? But if you said women watch less TV than men, that's cool. So yeah, you're close there, but you're so on the right track. And then I was like, dang it. But yeah, is that cool? And this is the last page. So the last one is a dependent sample. So this is a little tricky. Your average difference should be 0. That means there's no difference before and after, right? The alternative is that there is going to be a difference, and we usually make those one-tailed because we're looking to see if it actually improved in this case. But I was a little flexible on that as well. Degrees of freedom is 6. Here's our t-stat. So it's about 2.09. If you look up 2.09 on your t-table, and what row should we look in? Row 6. Let's look in row 6 and look for 2.09. Row 6, 2.09 is right in here, isn't it? So that means our p-value is between 0.025 and 0.05, right? If we made it one-tailed. And we're trying to say, and of course, and I was a little more particular on that because it raised the gym scores. And so, since it's less than 0.05, you reject the null because the p-value is between 0.05 and 0.025. Significant evidence the training worked. and we do our 99% confidence interval. I did this on purpose. Notice is 0 in this interval. And where did this 3.707 come from? Right here, right? Row right here, 3.707, 99%. And notice 0's in this interval now, isn't it? So it is possible it didn't work. Why is this like saying maybe it didn't work and this one is saying yes, it did work? What happened between these two parts? They changed the alpha level. What's the alpha level up here? 0.05. What's the alpha level really down here? 0.01. See? I just did that. I mean, obviously it didn't make any difference on this test, but I just did that to kind of show, be careful, because somebody could say, hey, it's significantly, better, and then somebody else can say, what if I change the alpha level? Which is why I think it's important to report p-value, so people can make their own judgment about what is significant and what is not. Yes?
I'm sure you saw it, but when I did a null hypothesis and it said the training technique is effective, I was thinking effective would be more than 2 standard deviations away, because then you couldn't argue. I don't know. Anyway.
Yeah, well, and this one's a little different because we have to use the t-table, but it is significant in this one because we looked it up. It's between 2.5 and I actually did this one on StatCrunch. It's at 4%. The p-value here is actually 4%. If you did it on,
My question, I guess, is can the null hypothesis be, does it have to be equals to 0?
Yes. Yep, it has to be equal to 0. That's like saying the average change before and after is nothing. Right? So like if I pre-tested you all over chapter 7, 8, and 9, and now I've just post-tested you over chapter 7, 8, and 9, my null hypothesis is you got no better. My alternative hypothesis is that your scores would get better. And I would say that would probably happen, right? But then you could prove significance that way, right? You could say, because it's paired data, you are testing against yourself. Those two testings are together. This is so, and there is one on the final, I know on this one too. I'm pretty 90, yeah, I'm sure. And the last one's a little tricky. It says there was evidence. That means there was significant difference, right? And they made this decision at 0.05. So if you think about it, that means they rejected the null. That means the result was out in here somewhere. The question is, would they have made the same decision if the alpha level was 0.1? And the answer is yes, they would have made the same decision because it's definitely out here. And the other one for 0.01 is maybe. If the p-value was out here, then yes, they would. If it's out here, no, they wouldn't. So that's why it's a maybe. And there was 58 points, and I did not curve it because we had like 4 or 5 people get perfects. We had essentially 10% of the class get a perfect score. So good job.